Okay, so we're going to take a look at exercise 1 on page 72 of the workbook. And this is another problem of the type where they give us a function, in this case x e to the negative x squared, and they ask us for the absolute max and the absolute min on an interval. Okay, and as you recall, there are two places that we need to look in order to answer this question. There are the endpoints, which are given directly to us in this case. Our interval is 0 to 2, so our two endpoints are x equals 0 and x equals 2. And then we also need to look at our critical points. Okay, which means that we need to take the derivative and figure out where it's equal to 0 or where it's undefined. Okay, now taking the derivative of this function is a little bit more involved than some of the ones that we did before. Okay, you can look at that and see that there's going to be a product rule and probably a chain rule involved as well. So let's start with the product rule, because this is x times e to the negative x squared. So we're going to have the first times the derivative of the second plus the second times the derivative of the first. Okay, and if we go on from there, that means that we're going to get x times, now we need the derivative of e to the negative x squared, which by the chain rule, we're going to get e to the negative x squared all over again, times the derivative of the u, which is negative x squared. That's going to turn into a negative 2x. Okay, and then at the end, we're just going to get e to the negative x squared times the derivative of x. And the derivative of x is 1. Okay, which we could even not write if we wanted to. All right, and normally, when we did this previously, we would stop at this point. But because we actually want to solve an equation involving the derivative, it's to our advantage to simplify this if we can. Okay, so notice that we've got an x that I'm underlining here and a negative 2x at the end. I'm going to put those two pieces together at the beginning into one negative 2x squared times e to the negative x squared. And then the second term, the plus e to the negative x squared times 1, is just plus e to the negative x squared. And notice we can do a little bit more algebra here. Okay, there's an e to the negative x squared in both of those terms, and so we can factor that out. It's going to make it easier. All right, so I'm going to pull an e to the negative x squared out of both of those. And if you do that, the first term, you're going to have a negative 2x squared left over, and in the second term, just a plus 1. Okay, there's our simplified formula for the derivative. There's no denominator here, so all we need to worry about is where that derivative might be equal to 0. All right, so let's set it equal to 0 and see if we can figure that out. All right, well, there are kind of two pieces to this expression that we have here. There's the e to the negative x squared at the beginning. If you think back to algebra for a minute here, e to a power can never equal 0. So if you were to take e to the negative x squared and set it equal to 0, you would discover that there are no solutions, which means that we don't even really need to worry about the e to the negative x squared part of this. What it really comes down to is when that second term, the minus 2x squared plus 1, is equal to 0. All right, so we'll set that equal to 0 and see if we can figure out what x is. All right, so we're just going to get the x by itself, so maybe add 2x squared to both sides. Okay, divide by 2. Okay, and we're going to take the square root of both sides of this equation, which is going to actually give us two solutions, either the positive or the negative square root of a half. Okay, and so we have come up with two critical points. But again, ask yourself, do we really need to look at both of those critical points? Our interval at the top of the page here is 0 to 2, and only one of those two numbers is in that interval. Okay, the negative square root of 1/2 is outside of the interval 0 to 2, so we can ignore it. And really, all we need to look at is the positive square root. Okay, so there's really just one critical point in this case. So we've boiled this down to our critical point and then our two endpoints up here. Okay, so we're going to make a table and just check what our value is at each of those 3 points. Okay, so in our chart, we are going to put 0. That's one of our endpoints. Square root of 1/2. That was our critical point. And then 2, our other endpoint. All right, we're going to take those numbers one at a time, starting with 0, and just see what we get when we plug them into our function. So f of 0, okay, if you plug it back into f of x, and remember that's this formula at the top of the page, we are going to get 0e to the negative 0 squared. You can double check me. That's going to turn out just to be 0. Okay, we'll do the same thing with the other 2 points. So f of square root of 1/2. Okay, this is a little ugly to write down. You can plug that into your calculator. Make sure to be careful with your parentheses when you do that. And out should come about 0.43. Okay, and f of 2, same deal. This time we're going to get a 2e to the minus 2 squared. And that turns out to be about 0.04 if we round it off. Okay, and to answer the question we're asked, we are just looking for the biggest and the smallest value on our table. All right, and the biggest value, okay, out of 0.43 and 0.04 looks to be the 0.43. We've just found our absolute maximum. Okay, and the smallest value, that would appear to be the 0, sitting right here. So f of 0 equals 0 is our absolute minimum.